Okay, so we're finally starting chapter 4 and we're finally getting into the trig part of our trig class. So we're going to start by talking about angles and rotations. So when we're talking about rotations, we're talking about moving from one point, such as point A, around a circle to point B. So we have two different ways of describing this. So magnitude is the angle and direction of rotation. And revolutions is how many full times around a circle the point moves. So it doesn't have to be a whole number of revolutions. It can be a fraction. It could be an improper fraction. It's just how many times around the circle you go. So one important thing to remember from geometry class is that the different directions that you rotate have different signs. So the positive direction is counterclockwise because that's the same way that the coordinates of a graph are labeled. And then if you go clockwise, it's the negative direction. So in our picture here, our point A is moving counterclockwise to get to point B. So we would say the magnitude is negative 50 degrees. And then the number of revolutions, well, if we didn't go one whole time around the circle, but the whole circle would be worth 360, and we went 50 degrees of that. So to find our answer, we would do 50 degrees over the whole 360. And we would reduce that, and we would get 5/36 of a revolution. Okay, so now we're going to talk about how to change revolutions into degrees. So we have pictures of different revolutions here, different turns. So like in our first picture, we start at point A, and then this arrow shows that we start here and we go all the way around the circle until we're back at our original starting point. So that would be one revolution, which is equal to 360 degrees. Here we're starting at point A, and we're moving to the other side of a diameter, and we know a diameter cuts a circle in half, so we would say that is a 1/2 revolution, and then half of 360 would give us 180 degrees. Here from geometry, hopefully you remember the box in the corner means 90 degrees, so that means we are going a 1/4 revolution around the circle with 90-degree angle of rotation. And then here, these are harder fractions to see, so that we gave you the fractions. So here we have a 1/8 revolution counterclockwise, so we have to remember that that is the positive direction. And so to find out how many degrees that is, you would do 1/8 of the total 360, which would give us 45 degrees, I believe. Let me just check our calculator real fast. Yep, and then we want to do a 2/3 clockwise rotation, so that would be a negative rotation. So to find the degrees, we would do 2/3 of 360, which is 240 degrees, but it's a clockwise rotation, so we make our answer negative. And then here we are going counterclockwise, so positive direction. And we can see here that we go one whole loop around the circle to get here. So here's just 360 degrees, and then we go, it says a 1/4 more, so that's a 90-degree angle. So to get our total, we might want to also change this to an improper fraction, so that would be 5/4. So we would do 5/4 times 360, which would give us 450 degrees, and it's a positive rotation, so we leave it as positive. So sometimes you have to figure out the magnitude of your rotation using a picture. So we're going to do two examples. So the first one, we are starting at the x-axis, and we are moving along the red line until we get to the ray that's pictured. So we know that half of the circle is 180 degrees. So we're going to start here and say that's our 0 degree. Here would be 90 degrees, and here would be 180 degrees. So it says that this right here is 35 degrees. So instead of going the whole 180, we're only going 35. So we can also see that this is a counterclockwise rotation, so it's positive. So to get our angle, we would do 180 minus 35, which is 145 degrees, and it's counterclockwise, so we're going to leave it as a positive 145. Okay. Over here, you always want to first look at your direction. So if we are starting here and moving along the red line, so there's our 0-degree mark, that means we are going in a clockwise rotation, which is a negative rotation. So we go all the way around one time, so there's our 360 mark. And then down here, we know that there's a 90-degree angle here, but we are not going through the 75-degree angle. So there's 75 degrees left in that quarter of the circle after we've gone past our 0 mark. So we need to figure out what this angle right here is. So to figure that out, we would do the 90 degrees in that quadrant minus the 75 degrees we are not using, which will leave us with 15 degrees. So this is 15. So to get our total angle of rotation, we would do 360 degrees plus 15 degrees, which would give us 375 degrees. And then it was a clockwise rotation, so our answer would be negative 375 degrees. Okay, so you have 2 OYO questions to do, so I want you to pause the video and just go ahead and do your 2 OYOs. Okay, so far in geometry, you've only ever measured things in degrees, and so in trig, we use this different measurement called a radian. So we're just going to start exploring what that means. So if we look at this picture, there are 2 circles, and they both start at center O. So the smaller one is of course smaller, so moving from point C to G along that blue line is a very short distance, and we can see that if we moved along the bigger circle from E to S, that is a longer distance, even though they have the same angle. We'll call our angle x degrees in the center. So even though they travel through the same angle, because the radii are different lengths, the points would travel different distances. So sometimes that can be really inconvenient. We want to know how to compare the angle to how far the point is moving. So in measuring a rotation in degrees or revolutions, that doesn't tell us anything about how far the point actually moves. Along the circumference of the circle. So to counteract that problem of not knowing how far it goes, they came up with this new way to measure angles, which is called a radian. And a radian is a unit of measurement that relates the length of the arc a point moves along to the angle. So what a radian does is it makes the angle, the central angle, which is like the angle x I labeled on the picture, so it's the angle at the center of the circle, it makes the central angle equal to the distance the point moves along the circle. When the radius of the circle is 1. We'll put that caveat in here. So a radian measure allows us to more easily compare the angle at the center to how far the point moves along the outside of the circle. So we're going to get into using these, and eventually we will be using mainly radians instead of degrees. So we're just going to start with an example. So we have circle A here and circle B on its perimeter. And we want to know if circle B started where it is and traveled all the way around the outside of the circle. We'll say it goes counterclockwise to keep it positive. How far would it have moved? Well, if it goes along the entire outside of the circle, it's traveled the circumference of the circle, which is of course equal to 2 pi times the radius. So we're going to get back and we're going to eventually use this formula to come up with a conversion factor. So then how many degrees did B move if you looked at the central angle? Well, that's just how many degrees are in a full circle, so that would be 360 degrees. So you're going to start hearing a lot about a unit circle. Some of you might have learned about it at the end of Algebra 2 last year. So the definition of a unit circle, the word unit in math means 1. So in a unit circle, the radius is always equal to 1 unit. So that could be 1 centimeter, 1 inch, 1 foot, whatever units you're working in. So it's just equal to one of them. So now we want to figure out if we rotate B along the circle towards C through this 45-degree angle, so that's a counterclockwise rotation, so it's positive, we want to know how far did it have to move. So we're going to make our radius here equal to 1, so that way this is a unit circle. And so if it traveled the whole circle, we know from the previous slide that the point would have moved 2 pi r, which in this case is equal to 2 pi times 1, or 2 pi units. So the full 360-degree circle would give us a 2 pi movement. But now we only moved 45 degrees of the circle, so we need to figure out what fraction of the circumference that is. So we would do 45 over 360, which would give us a fraction if we reduce of 1 over 8. So we're moving 1/8 of that 360, so we need to know what 1/8 of our 2 pi circumference is. So put it over 1 to make it fractions, multiply across, we get 2 pi over 8, which would give us pi over 4. So now, since this is a unit circle, when the radius is 1, the angle at the center of the circle is equal to the distance along the arc. So we just found out that that's a pi over 4 arc, so that means 45 degrees is also equal to pi over 4 radians. Okay, so you have a few more OYO questions, I think, on the bottom of your worksheet, so make sure you finish filling out your worksheet and then come to class ready to do some angle conversions.